All right, let's dive into a really fascinating new idea in artificial intelligence. What if, instead of just trying to fix an AI's mistakes after the fact, we could give it a teacher right from the moment it's created? Let's unpack how that actually works. We've all seen it, right? You ask an AI a question and it either just confidently makes something up. We call that a hallucination, or, it says something it really, really shouldn't. Well, this research goes after that problem right at its source. So, to really get the solution, we first have to wrap our heads around the problem. And that problem starts with the way these huge AI models learn in the first place. Think about it like this. The standard way to train an AI, called pre-training, is basically to feed it a giant chunk of the internet. It's kind of like telling someone to read every single book in a library. But, and this is the key part, there's no librarian there to say, hey, that book's fiction, or that one's totally outdated, or that one is just plain nonsense. The AI just absorbs it all, including all the flaws. And that is the absolute crucial point. The researchers behind this paper are basically saying that trying to fix these problems after the model is already trained is just too little too late. The bad habits are already baked in. You have to get it right from the very beginning. And this right here is their big idea. Instead of letting a new AI just wander through that chaotic, messy library all by itself, what if you gave it an experienced mentor to guide it from page one? So here's the setup. It's pretty cool. On one side, you have the new apprentice model, which is just starting its education. And on the other side, you've got a powerful, already trained master model that's going to act as its teacher. Now, this master model has two really important jobs. First, it's a rewriter. It actually goes through the training data, the books in our library, and it cleans them up, making them safer and just higher quality overall. Second, it acts as a judge, grading the apprentice's own attempts and letting it know when it's doing a good job. So how does this whole teaching thing actually play out? Well, it's a constant feedback loop that the paper breaks down into three really simple steps: rewrite, rollout, and reward. Here's how that loop works. First, the master model rewrites a piece of text to make it better. Simple enough. Then the apprentice gets its turn and tries to write its own version. That's called a rollout. And finally, the master model puts on its judge hat and gives a reward to whichever response was the best, which teaches the apprentice what good actually looks like. Now, this whole process is a type of something called reinforcement learning. And if that sounds super complicated, don't worry, it's not. It's really the same basic idea as giving a dog a treat when it sits. You use positive reinforcement for good behavior, and the AI learns way, way faster. And what's really cool is that we can actually see the exact instructions they gave the master model to turn it into a safety judge. It's a super clear, simple prompt. Please tell me if the text is safe or not, and then it just asks for a final yes or no. That's it. And they don't just do this for safety. This shows a very similar prompt they use to judge the overall quality of the writing. The master model is asked to compare two options and just pick the one that's more coherent and factual. It's pretty much like a teacher grading essays for clarity and correctness. Okay, so that's the whole theory. You have a master model teaching an apprentice model through this cycle of feedback and rewards. But the big question, of course, is, did it actually work? Did the student pass the final exam? Let's take a look at the results. The very first result is a real showstopper. The new model, the one trained with this self-improving method, hit an average safety score of 91.1%, and that is a massive improvement. And this chart right here really shows you what that number means. The baseline model, the one trained the old-fashioned way, it barely scored 77% on safety. Our new apprentice model, it jumps all the way up to over 91%. That is a huge leap forward in making these AIs more reliable and less likely to generate harmful stuff. And it's not just about safety. The model also got way better at, telling the truth. It showed a 36.2% relative improvement in factuality. In plain English, that means fewer hallucinations and a lot more grounded, accurate answers. I mean, this whole report card just tells the story. Across the board, the new self-improving model just crushes the baseline. When you put them head-to-head on quality, it wins over 86% of the time. The factuality score jumps from about 42 to nearly 58. And, as we saw, that safety score gets that massive boost. It's a clean sweep. But maybe the most impressive thing of all is that this method works right from day one. When they trained a completely new model from scratch this way, its safety scores shot up from 85% to an incredible 97.5%. This proves you can build safer AI from the ground up, not just try to patch it up later on. So, what does this all mean for the future of AI? This isn't just some small tweak we're talking about. It's a pretty fundamental shift in how we can think about building these models. So, why does this matter so much? Well, because this method lets us build better, safer models from the very start. It creates this powerful cycle where better models can help create even better ones. You can see how that could get really powerful fast. This could save a ton of time and money on all those difficult fixes after training. And most importantly, it could lead to AI systems that we can actually trust a whole lot more. And this all points to a bigger philosophy, which is captured perfectly in this quote the researchers cited. The big idea is to stop trying to explicitly teach an AI every single little skill, and instead create systems that incentivize the AI to learn the right behaviors on its own. It's about teaching it how to learn, not just what to learn. It's about motivation, not just memorization. Which leaves us with a really fascinating final thought. We now have a pretty good idea that an AI can be taught to be safer and more factual by another AI. But if it can truly learn how to teach itself, what's the next lesson it's going to master?